The darkness of the ocean at night is almost absolute. Light fades quickly underwater, and vision becomes unreliable long before life disappears. Yet some animals move through this darkness with incredible precision, chasing prey, avoiding obstacles, and navigating vast environments without ever needing to see clearly. They rely instead on sound. For them, the world is not something they look at, it's something they hear bouncing back. Imagine a hunter racing through pitch-black water at speeds of over 30 kilometers per hour, dodging obstacles and pinpointing fish smaller than a human hand. That hunter is the dolphin. Dolphins use a powerful form of echolocation, sending out rapid clicks that travel through the water and bounce off objects around them. When those echoes return, a dolphin's brain interprets the timing and intensity of the sound to build a three-dimensional acoustic map of its surroundings. It's so precise that dolphins can detect the difference between materials, recognize shapes, and even sense objects buried beneath sand. In murky water where eyesight fails, their sonar becomes their superpower. But dolphins aren't the only marine navigators using sound. Deep in colder oceans swims the beluga whale, often called the canary of the sea because of its remarkable vocal range. Beneath thick Arctic ice, visibility is almost non-existent, and breathing holes can be miles apart. Belugas send out clicks and whistles that bounce off ice formations and underwater terrain, helping them locate openings to the surface. In an environment where a wrong turn could mean suffocation under frozen water, their acoustic navigation becomes a life-saving tool. While whales and dolphins dominate underwater echolocation, another master of sound navigation glides silently through the night sky. Bats have been astonishing scientists for centuries because they hunt with extraordinary accuracy in complete darkness. A bat emits high-frequency chirps, often too high for humans to hear, that spread through the air and reflect off insects, trees, and walls. Within milliseconds, those returning echoes allow the bat to determine an object's distance, speed, and direction. A bat can even detect the fluttering wings of a tiny moth and adjust its flight mid-air to intercept the insect with pinpoint precision. For an animal barely the size of a mouse, it's an incredible demonstration of biological sonar. Not all bats hunt insects, though. Some species, like fruit bats, rely more on vision and smell, but certain bats that feed on nectar or fruit still use sound to navigate dense forests at night. In thick vegetation, where branches crisscross and leaves block the moonlight, echolocation prevents collisions and guides them safely to food sources. Their calls may be softer or lower in frequency than insect-hunting bats, but the principle remains the same. Sound reveals what eyes cannot. Birds may seem like creatures of sight, but a few have evolved a surprising ability to navigate using sound as well. The oilbird, found in caves across South America, spends its nights flying through forests in search of fruit, and its days roosting deep inside dark cave systems. Inside these caves, light never reaches the walls. Oilbirds produce sharp clicking sounds that bounce off cave surfaces, allowing them to avoid stalactites and narrow passages as they fly. It's one of the rare examples of echolocation in birds, proving that the strategy isn't limited to mammals. Another bird that uses a similar trick is the swiftlet. These small birds live in caves across Southeast Asia and the Pacific Islands. Like oilbirds, they emit rapid clicking sounds while flying in total darkness inside their cave homes. Those echoes guide them through twisting chambers where a single mistake could mean crashing into rock walls. Unlike bats, swiftlets use audible clicks rather than ultrasonic calls, meaning humans standing inside the cave can actually hear the bird's navigation system in action. Back underwater, sound navigation becomes even more fascinating when we consider the sperm whale. This enormous predator dives deeper than almost any other mammal, plunging more than a kilometer beneath the ocean surface. At those depths, sunlight vanishes completely. To hunt giant squid in the abyss, sperm whales produce some of the loudest biological sounds on Earth. Massive clicks that can travel kilometers through the water. When those clicks strike prey or underwater features, the echoes guide the whale through a landscape of darkness. Their sonar is so powerful that researchers believe it can temporarily stun prey. Then there are porpoises, close relatives of dolphins that use echolocation in a slightly different way. Porpoises produce extremely high-frequency clicks that are nearly impossible for predators like killer whales to detect. This stealthy sonar allows them to scan their environment without broadcasting their location to danger. It's a reminder that echolocation isn't just about finding food. It can also be about survival. Shrews, tiny mammals that resemble mice, also rely on sound to navigate their environment. Unlike bats or dolphins, their echolocation is relatively simple. They emit soft chirps or squeaks and listen for echoes that bounce off nearby objects. In the dense leaf litter where shrews hunt insects, visibility is limited and obstacles are everywhere. These small sound cues help them detect barriers and move quickly through cluttered terrain. It's not as sophisticated as bat sonar, but for an animal only a few centimeters long, it's incredibly effective. Perhaps one of the most surprising sound navigators is the blind cavefish. Living in underground rivers where sunlight never reaches, these fish have lost their eyesight over generations of evolution. Instead, they rely on subtle pressure waves and reflected sound vibrations in the water. By sensing how water movement changes around obstacles, they can detect cave walls, rocks, and other fish nearby. It's not classic echolocation, but it's another example of how sound and vibration can replace vision in extreme environments. What ties all these animals together, from dolphins slicing through ocean waves to bats darting through the night sky, is the same basic principle. When light disappears, sound becomes the map. By sending signals into their surroundings and interpreting the returning echoes, these creatures transform darkness into information. They build mental images of spaces they cannot see, navigating complex worlds with astonishing precision. In many ways, echolocation reveals just how flexible life can be. Evolution doesn't simply rely on sight as the default sense. When environments become too dark, too murky, or too complex, nature finds another solution. It turns the world into an acoustic landscape where every click, chirp, and pulse carries meaning. And for the animals that have mastered it, silence isn't empty. It's filled with echoes, waiting to be understood.